This is a video demonstration of problem Try It 9.8 from Alexander Holmes OER text. Problem Try It 9.8 reads the following. The mean throwing distance of a football for Marco, a high school freshman quarterback, is 40 yards. Standard deviation is 2 yards. The team coach tells Marco to adjust his grip to get more distance. The coach records the distances for 20 throws. For the 20 throws, Marco's mean distance was 45 yards. The coach thought the different grip helped Marco throw the ball further than 40 yards. Conduct a hypothesis test using a preset alpha of 0.05. Assume the throw distances for the footballs are normal. Now, in terms of, before we even get into solving this problem, one thing to point out is that last statement about the population, or assuming that all of the distances are normal, could lend us to a rightful assumption that we're going to use a z-distribution. However, our sample size is 20. In this case, we've talked about it before. The calculation versus a t and a z are very, very similar. In fact, these two distributions are closely related, right? The limiting distribution for the t distribution is, in fact, the z distribution. Over a large sample size, those t distributions get ever increasingly close to a z distribution. So we could, by all rights, use a z distribution with that last statement. However, in this case, it's a bit more conservative when we get to the selection of a critical value to compare this using a t distribution. So that's what we're going to do. We're going to follow kind of the accepted rule of our sample size is less than 30. We are going to use a t distribution, and again, understand those calculations are basically the same. It's just a bit more inherently conservative to use a t distribution. In terms of solving this problem, our given information. So we are given a hypothesized mean equal to 40 yards. And then the coach goes in, makes the adjustment to how Marco throws the ball, and then he runs a sample, has Marco throw the ball 20 times, tracks how far the ball goes, finds that from the 20, the average distance is 45 yards, standard deviation is 2 yards. And then we've got this alpha of 0.05. So basically our type 1 error is 5%, 0.05, basically the chance of making a decision wrongly about our null hypothesis. Step number 1, everything about this problem relates to a mean. So we're dealing with a hypothesized mean. In this case, in terms of understanding what we're researching or what the alternative is, we're trying to figure out now, does Marco in fact throw the ball further than 40 yards based on the change in his grip? Alternatively then, Marco would still be at 40 yards or less. Step number 2 is our significance level of 0.05. Step number 3, right, we've addressed this early on and said we're going to choose to use a t calculation. All right, and that t calculation is our x bar minus our hypothesized mean over the standard deviation divided by the square root of n. Again, we selected this formula because we're dealing with one sample. If we were dealing with two samples, we would select a different formula, and we have some different theories going on in terms of how we're going to compare those different possible populations. But again, in this case, we've got a singular sample mean, so that drives the selection of this particular formula. Our singular sample mean was 45 yards minus 40 over 2 divided by the square root of 20. If we run that calculation, we come up with this positive 11.18. It's a pretty significant number, statistically speaking. It's going to drive a really clear conclusion as we run through the rest of the hypothesis test. Step number 4 is how we put together our decision rule in terms of how we're going to evaluate our critical or our calculated value versus our critical value. Again, we're dealing with a t distribution. It's a one-tailed test. We know it's a one-tailed test because we have this inequality in our null and alternative hypothesis, or these two inequalities. The one that we're going to pay close attention to in putting together this decision rule is basically looking at the direction of the inequality in the alternative hypothesis. Tells us that we're dealing with the positive side of the number line. The rejection zone here, the size of that area of our distribution is 0.05. We're dealing with a t distribution, so we've got to look at our degrees of freedom. In this case, our degrees of freedom are 20 samples minus the one sample that was conducted, got us to 19 degrees of freedom. If we look at our standard, we look at our student t's distribution charts. We're going to go down basically to 19 degrees of freedom and over to 0.05, which represents our alpha. That's going to tell us that our now T critical value is going to be positive 1.729. We are then going to say we're going to reject H sub 0 if our T calculated value over here is greater than our T critical value right there of 1.729. When we go down to making a decision, then basically we're saying, where is this calculated value? Where does it exist in my probability or my decision rule that I put together? And it's way out here at positive 11.18. We very solidly would say we are going to reject H sub 0. We reject H sub 0, and now we're left with the alternative. Statistically speaking, it is very clear that the change in the grip is increasing Marco's throwing distance. This is a very persuasive number. Later on, we'll talk about how we would solve this problem using a p-value, and it would be even more evident that this is a statistically significant value. But again, even looking at a critical value test, it is abundantly clear that the change in the grip has increased Marco's throwing distance.